Today we are happy to welcome you to the session on the rolling review of requirements. So if you're curious about what it is and how the requirements for ocean observations are set, you are definitely in the right place. We have with us our trainer, Sabrina Speisch from École Normale Supérieure, whom I will introduce in just a second. Oh, now we have a few people joining. Very good. Hello, everyone. Welcome. Just a few housekeeping rules for the training. We are recording the session to make it available afterwards on our website and on social media channels. So be aware of that. It will also be made available to you, so you'll be able to revisit the training session. We are, of course, very well open to questions and comments and discussion. So if you have anything that you would like to add to the conversation, please feel free to put your questions or comments in the meeting chat or raise them directly after the presentation. During Sabrina's presentation, please keep your camera and microphone off and then turn them on for questions and comments later on, because we'll only use the presentation to the recording of the presentation. So the discussion afterwards will not be made public anyway. So don't worry about that. If you are interested in this training series and would like to attend our next trainings, we would welcome that very much. So please be aware we have 2 trainings coming up this year. One will be at the end of October on best practices and standards for ocean observations. And the next one will be at the end of November and will address the AI-driven quality control and uncertainty quantification in essential ocean variables. So if you'd like to register for these trainings, you need to go to our Eventbrite page and register for them individually, and then you will receive the links to connect. Yes, and if you would like any information about our resources or future trainings or any other events that our project OPSI4CLIM is providing, then please follow us on either LinkedIn or Blue Sky, or check out our website where we publish all the information, both about upcoming events, but also the resources that we publish afterwards. And so without further ado, I introduce our trainer for today. Sabrina is a full professor of oceanography and climate sciences at ENS in Paris. She's also the member of LMD and IPSL. She's co-chairing the Ocean Observations Panel for Climate under WIGOS and WIGOS. She's also the co-chair of the UN Decade of Ocean Sciences program in Ocean Observing Co-Design. And she's a member of the scientific steering group developing the new Earth System Modeling and Observations core project of the World Climate Research Program. So really an excellent trainer, and we're very excited to have you here with us, Sabrina. Thank you so much for joining. And I will now move to your presentation.
Thank you very much, Justina. So good morning. Just I wait the little slide and then I go.
Yes, here we go.
Okay, good morning, afternoon, evening for everyone, and thank you for being here. As I am involved in the rolling review of requirements, which is a process led by WMO in terms of the ocean, because there is an ocean applications now in this process. I will try to provide a brief summary on what is the rolling review process in general, with an emphasis on the ocean and how the OPSI4CLIM European project is contributing to it. So next slide, please. So Earth systems are tightly interconnected, as you know. So the atmosphere, ocean, land, cryosphere, and biosphere interact on scales from local to global. To understand that today and predict their behavior, fragmented or isolated observation are no longer enough. We need an integrated Earth observing system that brings together diverse observations, ensure interoperability, and makes data accessible as a global public good. This is the only way to provide a reliable weather forecast, track climate change, and produce reliable adaptation information, manage resources, early warning system, and support society facing growing environmental risk. Global Earth observation give us the essential data to monitor and predict our planet system. They come from satellite, ground stations, ships, buoys, and aircraft. But to be effective, they must be coordinated. That's where the World Meteorological Organization rolling review of requirements process comes in. It connects what user needs with what our observing system can provide, identify gaps, and guides the evolution of the global observing system. Next slide, please. The rolling review of requirements is a systematic process established by the World Meteorological Organization, WMO in the slides that will follow, to collect, analyze, and update user requirements for observation across all WMO application areas, and I will come to that. At the beginning was weather forecasting, then climate monitoring, but today we have also the ocean and the hydrological cycle, and there is other application. I will list them. It compares these requirements with the current and also planet observing capabilities in order to identify gaps and set priorities for the global observing system. So it ensures that observation network and system evolve in response to the need of diverse applications, provide a structured way to balance user requirements, what is needed, and observing system capabilities, what is available or will be available, support cost-effective investment and international coordination in observing networks. So observing networks are in general funded by nations. Serves as a common language for scientists, operational services, and decision makers. It was developed in the 90s with the framework of the WMO Global Observing System that was called the GOOS, GOS only, without the second O. Initially applied mainly to weather and climate observation, but it has been progressively extended to cover all WMO application areas that I will list shortly. And now it forms the backbone of how the WMO integrated global observing system, which is called WIGOS, evolves and interface with user needs. So next slide, please. The evolution of global observing system is driven by user requirements that can be scientists or operational services, policymakers, etc., and was coordinated by the World Meteorological Organization and some other programs that are supported by WMO or the WMO and the United Nations Organization. The WMO Integrated Global Observing System, WIGOS, is the combination of satellite-based and surface-based. So for essentially atmospheric scientists, they call surface-based. We call it in oceanography in situ observations. So there is some language adjustment that need to be made sometimes that contribute information for WMO programs. The observation come from satellite managed by Space Agency and from a number of observation networks managed by government agency or commercial operators. So WIGOS is overarching WMO framework and integrates all WMO observing systems. So if you go to a WMO website, you will find a lot of acronyms that are all observing systems. So you find GOS, GAW, so GAW, WHOS, GCOS, etc. And so I try to coordinate this comprehensive global system to improve interoperability and integration across all the subsystems, atmosphere, ocean, hydrology, and climate, to make the use of existing new technologies, avoid duplication, ensure a sustained high-quality observation, provide governance, standards, and coordination mechanism for observation. So if you look at the list of the different type of observation, you find that in this list there are many specific points, bullet points, that are essentially atmospheric observation, and the ocean observation is just one bullet point. So the system is evolving and is starting to upgrade their language, but we are still a bullet point in terms of ocean, but it is getting expanded. So next slide, please. So this WIGOS is as I said, is a key components of the WMO rolling review process. It has now a vision. So in the end of the 2010, it has been established a vision. It is a strategic long-term outlook for how the WMO integrated global observing system should evolve by the year 2040. It describes a technically and economically feasible yet ambitious observing system that supports all weather, climate, water, and related environmental services. It set the high-level targets and guiding principle to steer the evolution of the observing system in WMO and all the related observing program, and by member state over the coming decade. So it has a number of principles and policies, and I invite you to take a look on all the documentation that is on the WMO website. But it has also a chain loop where you see the observing capabilities, how they are related to the user requirements, with arrows that go on to gap analysis, implementation plan, long-term vision, and program of member and an agency. So there is a kind of loop that that intercept all these parts of the system. So next slide. So how we set the user requirements. So user for us, for example, can be ocean operational services or climate services, is all listed in OSCAR, that is called the Observing System Capability Analysis and Review Tool. OSCAR is an online WMO information system that supports the rolling review requirement by providing a repository of user requirements. So all the user requirements for the ocean application areas will be posted there. So user requirements for observations, and in OSCAR you need to look for requirements then. And then also it lists all the metadata on observational capabilities of satellites, surface and ocean-based instrument. And this is in space and surface directories. This process ensures transparencies and accessibility of requirements and capabilities. It provides a central reference for observation planning, gap analysis, and system designs, and helps space agency, national meteorological services, and national agencies and government, together with other stakeholders, to coordinate investment. So next slide, please. Maybe, yeah. Go to the next. So the full rolling review requirements is a four-step process. So we need to define the requirements, and this is made by the user of this observation. So we collect the user requirements for each WMO application areas. And these include the resolution, accuracy, coverage, and timeliness of the observations. They assess the current and planned capabilities in this process. So these document observational capabilities for all, so satellite, in situ, ocean, atmospheric, etc., using OSCAR. And then there is a comparison and identification of gaps, comparison between how well current planned system meet requirements. And we need to highlight gaps, redundancy, and area that need improvements. And after that, there is a development of guidance and recommendations. So there is production of a statement of guidance that is called SOG for each application areas and provide priorities for future observing system evolution under this WMO integrated global observing system. Alias WIGOS. So in terms of compare identify gaps, maybe I can introduce how it is usually done in numerical weather prediction and in some application for the moment in the ocean observing system. So we use ocean observing system experiment that are called as acronym OSIS, and this is like we take the observing system, we look at how it compare with the real observations, of course, independent observations, assessment of the system, and then we see how many or how they need to be distributed, these observing platform to provide the best answer. Also, to guide future observing capabilities, we can use the observing system simulation experiments, where we use just numerical simulating the observing system, or we also assess in the forecast the error contribution or the forecast sensitivity to observations. This is done with a forecast system. So there are already some quantitative tools that of course have their limitation, but is better than just an expert assessment. So we use all this when possible, all this kind of tools. Now I go into the ocean and I will try to provide some where we are on this. But before that, I would like to list the actual application areas of this rolling review process at WMO. So of course, it started with numerical weather prediction that are global or can be high resolution. Then there are also some nowcasting and different, still related with numerical weather prediction, and different seasonal or machine learning forecast. And then there is also the aeronautica meteorology, and it has been at atmospheric chemistry. And now we have also ocean applications, and I will describe what these ocean application areas include. Then agriculture, meteorology, hydrology, global climate observing system, climate applications, and space weather. So next slide, please. So of course, the ocean has came up because when we look at the weather now, we know that the ocean is more than just sea surface temperature, a boundary limit for numerical weather forecast. And if we have a subseasonal to seasonal forecast, you cannot do something skillful without the ocean. So actually the ocean came up in the attention of the WMO system more than before, because it is really important. The ocean plays a crucial role in regulating weather, climate change, and extreme events, and absorbing 90% of the excess heat caused by greenhouse gas emission, and sequester around a quarter of anthropogenic carbon emitted annually. So it is really a system that is bejoined not only the weather forecast or climate, but also early warning system of different type, sustainable ocean economy, ocean health, fishery and food security, but also research and exploration. So it has a really strong societal and economical value. So we need the observing system to really assess the states and provide information for these different applications. So WMO in the past has defined, so next slide, please, what are the starting case for ocean applications. So ocean applications have been listed as ocean forecasting and real-time monitoring, coastal forecasting, ocean climate monitoring and services, tsunami monitoring and detection, so part of the early warning system, marine environmental emergency response, maritime safety, ports to open ocean, and ocean BGC cycles. So these have been given, already decided, and have been really what has been the focus of the first exercise. And this first exercise has been undergone under the responsibility of the Global Ocean Observing System, and also in interaction with the International Ocean Council. I don't remember, CX Council, it must be Council. And such as ocean forecasting, real-time monitoring, etc. So if we go to the next slide, I will introduce what was expected in the statement of guidance. So a statement of guidance for this in this process is a document produced for each WMO application area that summarizes how well existing or planned observing system meet the requirements, where the critical observational gaps lies, which type of observation would bring the greatest benefit if improved, and it translates the outcomes of the rolling review of requirements into concise policy relevant advice, and provide the guidance to decision makers, so the nation that essentially funds the observing system or space agency, on priorities for observation investment. It serves as benchmark for progress in addressing gaps. So the Global Ocean Observing System, with under Emma Eslop of the Secretariat of WIGOS, has been trying to establish this statement of guidance under these different application areas, sub-areas for the ocean. And it has lead as WIGOS is leading in the coordination of the science and the system itself in terms of Global Ocean Observing System, delivering to research, operational services, and society, mandated by governments under the United Nations and led by the Intergovernmental Oceanographic Commission of UNESCO, and building partnership across research community, governments, and private sector. So next slide. So WIGOS, just for those that do not know it, is comprehensive of 84 countries contributed to the Global Observing System that is pictured in these images, with 13 global observing networks that are ships, ghost ship or volunteer ocean observing vessel, Argo floats program, etc. And 4 that are today emerging. They have 12 active biological and ecosystem essential ocean variable observing communities. They are undertaking more than 120,000 observations per day. We have 18 national focal points and 14 regional alliance, and 3 are more that are associated. So next slide, please. The WIGOS works based now on 36 essential ocean variables, which the acronym is EUVs, and some of those are also essential climate variables. This framework of essential ocean variables is critical, and it is it's meant that underscore the critical ocean measures that allow the efficient monitoring of state and health of the ocean. This physical, biogeochemical, biological, and cross-disciplinary variable contribute to various international framework and convention, such as the Sendai Framework for Disaster Risk Reduction, United Nations Framework Convention on Climate Change, Convention on Biological Diversity, etc. And move beyond a focus on a single platforms, programs, or region, a connected and coordinated system. And established critical ocean measures that allow efficient monitoring of this system. So if we go to the next slide, we found how these foundational data that are coordinated by WIGOS are the start of many value chains and products. So we have observational services that are different. There is a disaster risk reduction, but also numerical weather prediction or ocean predictions, climate, so with the Paris Agreement, UNFCCC, but also ocean health with sustainable ocean management for the Sustainable Development Goal 14 and other different framework, including the plastic trade. So if we go back now to the rolling review of requirements, this has been a process where it has been concluded and under WIGOS, and it has been providing a statement of guidance. So to do this, WIGOS has led this process in connection with IOC, WMO, and other external team. It has established 6 areas, different areas teams, with the one on biogeochemistry that was not yet ready, but is activating very efficiently now. And of course, some areas are more mature than others, and but this has all described in this statement of guidance. They have created a definition, sample application, and overlaps defined with would need to be covered. Identify 37 variables, requirements, synthesis of gaps for 10 high-impact variable clusters. I will show them. Recommendation for 8 high-impact variables in order to highlight, address the impact across different areas, and also a link to communities and WIGOS networks. And risk, they have added a risk and sustainability page, and also an explanation text on the rolling review of requirements process that is pretty new in the ocean area. So this is an example of the evaluation with different colors showing what is really as a highest priority in red, medium priority, and low priority across the different application areas that have been decided for the WMO ocean rolling review requirements, a different variable, current, salinity, temperature, etc. So you can, this was a first exercise, and I think it has taught a lot, and of course need to be improved in the coming years. If we go to the next slide, in terms of all this system, of course, the ocean climate monitoring service intercept some of the other areas, sub-areas, and it has been constructed in a way that is, of course, working with different experts, trying to be homogeneous in this heterogeneous world. But of course, yes, how it has been constructed probably need a guidance of process that can be applied for further cases of ocean application areas that maybe will be developed in the future, and also how other areas can get inspired by what can be guided for users and the experts in all this cycle of the rolling review of requirements process. So if we go to the next slide, OPSI for CLIM, the European project, is focusing on climate. Ocean is a sub-application area. So climate is a general application areas in WMO, but the climate underscore different applications. So we have sea level, ocean transport that bring properties from one place to another. There are also extremes like marine heat waves and stratification, which is changing. Sea ice is changing. So OPSI for CLIM trying to provide a guidance based on these different approach that are developed in this European project. So we define the process and they define the needs in a kind of guided way and accompany the expert and the user in this process. And this is in interaction with EuroGOOS, the European Ocean Observing System, and the different framework of the European Commissions. Trying to deliver a strong and coordinated input to the global collaboration for addressing large-scale and global climate information requirements, as well as climate-linked marine extreme. And this is what we are trying to produce by the end of the project, and I hope that we will be useful. And in any case, we'll be interacting, we are constructing it inside the project in interaction with WMO and GOOS, but we will provide also ask for external input in this year, in these next months that are coming up. So I would like to thank you all for being here. And I would just to remind here that a sustainable, better design and fit for purpose observing system is enabling human society and a living system to adapt to sustainably and developed solutions, create new opportunities, empower growth of sustainable blue economies, support a strong linkage between observing enablers, operators, and end users. So thank you very much for being here.